Recall from previous section this simple, the integral from a to b of f of x dx. This represents the area under the graph of f over the interval a to b, means from x equals a to x equals b, if you remember this. So if I graph any random function f and say this is from a to b, let's take a c between a and b somewhere, any number c between a and b, and draw the vertical line. Then what we need to get out of this, from a to b, there's a property here says you can, if you go from a to b, you can go from a to c. So basically find the area under the curve from a to c plus the area under the curve from c to b. So it's kind of like split from a to c. Whatever this ends up with, the next one starts with, even if there's no figure. Let's say we are asked to find the area under the graph of y equals f of x from -3 to 6, where the function f of x is given as a piecewise function, x squared, for x less than or equal to 2, or 8 minus x for x bigger than 2. When you look at something like this, it might look, wow, this is so difficult. What am I going to start? How should I do this? But if we think a little bit about it, they want us to go from -3 to 6. Let me draw a number line, just a number line, -3 to 6. Well, they said use the function x squared when x is less than 2. So there's a 2 here somewhere. So over this interval from -3 to 2, use x squared. Above 2, from 2 on, means up to 6. Use the other function, 8 minus x. So to set up the area, integral area or area, you go from -3 to 2, use the first function x squared, dx, and go from 2 to 6 for the next function, 8 minus x. So now the integral for x cubed is, x squared is x to the third over 3 from -3 to 2, plus the integral of 8 is 8x. The integral of x squared plus 2. All this from previous section. So now to evaluate this, we open 2 parentheses for the first one, plus 2 parentheses for this next one. Put the 2 in. 2 to the third over 3 minus -3 to the third over 3. Sorry. -3 to the third over 3. Next one, 8 times 6 minus 6 squared over 2, and 8 times 2 minus 2 squared over 2. That gives 8 over 3 minus -27 plus 27 over 3 plus 48, 36 over 2, 18, 16 plus 4 over 2, 2. This is 35 over 3. The next part is 30 minus 16, 14, 16. So it becomes 36 plus 48 if you combine the two fractions. 83 over 3. That's the area under the curve. Another example similar to this one. Find the area of the region located under the graph of f over the interval -2, 3 if f of x equals -x squared plus 5 for x less than or equal 0, x plus 5 for x bigger than 0. At least everyone tried, maybe. So we're going from -2 to 3, and they said if it's less than or equal 0, use the first function. If it's bigger than 0, use the other function. The area is the integral from -2 to 0 of -x squared plus 5 dx plus the 0 to 3 x plus 5 dx. So that's -x cubed over 3 plus 5x from -2 to 0 plus x squared over 2 plus 5 x from 0 to 3. Open 2 parentheses for the first one plus 2 parentheses for the next one. This way the negative sign doesn't bother us. If you substitute the 0 in, you're going to get 0 plus 0. There's a negative there. -2 to the third over 3 plus 5 times -2. So remember, we substitute the top one first. Always. Same thing with this one. Plug in the 3 in, then the 0. Negative. Here we get -8 by +8 over 3 minus 10 plus this is 9 over 2 plus 15 minus 0. So what do we get? -8 over 3 plus 10 plus 9 over 2 plus 15. In return, this stays the same, the next fraction the same, and 5 plus 15, 10 plus 15, 25 over 1. So the LCD here is 6, so you multiply by 2 by 2, by 3 by 3, by 6 by 6. -16 over 6, 27 over 6, 150 over 6. 150 plus 27, or these two together, is 11, so that gives 161 over 6. Now, sometimes if we have, let's say, two functions, say this is f and another function g, from a to b, let's say. So we want to find the area of this region bounded by two graphs. In this case, the area is always defined as the integral from x equals a to x equals b, the top graph minus the bottom graph, dx. And in our case, we would say it's the upper graph is f, so it's the integral from a to b, f of x, minus the lower graph or the bottom graph is g of x, all dx. That would give us the area bounded by the two graphs. We're going to look at an example now. we are interested to find the area bounded by the two graphs, as you can see, which I'm shading right now. So let's say f of x is given as 4x minus x squared, and g of x, the equation of it, is x squared minus 6x plus 8. Find the area of the region, or the yellow region, on the right side. Well, remember how we start with this one. We said is the integral from a to b. So where did they meet the first time? It's from 1 all the way to 4. So imagine you travel from left to right. So it's 1 to 4. The upper curve is f. So f of x minus g of x dx. Now we substitute that in. 1 to 4. F of x is 4x minus x squared minus g of x, x squared minus 6x plus 8. Now we need to find how to integrate this. Okay, so how do we integrate this? First thing we do, besides integrating one at a time, we can simplify first. This is the integral from 1 to 4. 4x minus x squared, multiply the negative in, dx. Then is the integral from 1 to 4. There's negative 2x squared, combine like terms, 10x minus 8 dx. Now we can integrate them one at a time. X squared is x cubed over 3 plus 10. X is x squared over 2 minus 8x from 1 to 4. You can reduce this to make it 5. Now we open two parentheses separated with a negative sign. We substitute the 4 in, so you get negative 2, 4 to the third over 3 plus 5, 4 squared minus 8 times 4. We do the same thing for the 1 cubed over 3, 5, 1 squared minus 8 times 1. 64 times 2, negative 128 over 3. 16 times 5 is 80, minus 8 times 4, 32. So this is minus 2/3, becomes plus 2/3, minus 5 plus 8. You can combine these two fractions into negative 126 over 3. This one here goes as, so 80 minus 32, 7, 10, 8, 48, minus 5 becomes 43, plus 8 is 51. Notice if you divide 126 by 3, you get 42, negative 42 plus 51. The answer is simply 9. Now, notice how when we go back up, it showed us from 1 to 4, but that doesn't happen all the time. Like it goes, the region starts at x equal 1 to x equal 4. Let's say it's not given to us, but they give us the functions. F of x, note, f of x is 4x minus x squared, and g of x is x squared minus 6x plus 8. And we would like to know how to find where do they intersect. Say it like this. We need to know from where to where, like from what point to what point. To find points of intersection, we set them equal to each other. So you set f of x equals g of x to find points of intersection always. And so I have 4x minus x squared equals x squared minus 6x plus 8. And we need to solve this equation. It's quadratic, so I'm gonna add x squared to both sides to get the x's and subtract 4x on both sides. We get 0 equals 2x squared minus 10x plus 8. Everything is divisible by 2. Divide everything by 2 to make the numbers smaller. Now it's factor. It's x minus 4, x minus 1. From here you see x equals 1 and x equals 4. See, that's what was the setup for this. From x equals 1 to x equals 4. So that is an important part to learn. Example, find the area of the region bounded by the graphs of y equals 4 minus x squared and y equals 4 minus 4x. First thing I personally would do is graph them. You can use decimals if you like. Use decimals. It's on online. This is a parabola that opens downward and it goes up to 4. So it goes this way. The other one, if x is 0, y is 4. If y is 0, x is 1. It's a straight line. So the region bounded by the two graphs, it's this. Again, if you don't want to graph it, it's okay, but it's good to see it. In this case, I want to find where do they intersect. It seems they intersect at 0 here and at some other point that I don't know what it is. So to find their point of intersection, we set them equal to each other. Add x squared to both sides and subtract 4 on both sides. You can factor x out, x minus 4. So that gives us x equals 0 or x equals 4. Then the area is the integral, remember, from a to b. That's what we started with today, f of x minus g of x dx. So the upper one minus the lower one, or the top minus the bottom. And I will let you finish it up. Okay, so we go with the integral, as you can see, from 0 to 4. What's f of x? F of x is the higher one, the 4 minus x squared, minus the lower one is 4 minus 4x. 0 to 4, 4 minus x squared, multiply the negative in, minus 4 plus 4x dx. Then we combine like terms, the negative x squared stays, these cancel out, plus 4x dx. Then integrate the first one, negative x cubed over 3 plus 4x squared over 2 from 0 to 4 by 2 1 by 2 2, open parentheses as always. It's always good to have zeros, easy to calculate. Substitute the 4 in, then the 0 in. Negative 64 over 3 plus 32. Multiply by 3 to combine the fractions. Negative 64 plus 96 over 3. 32 over 3 is the area. Sometimes what happens, how do you know if you don't graph it, how do you know which one is higher? Probably you won. So in this case, what you do, you might get the opposite answer if you swap f and g. So if f and g get swapped or switched, like you make f g g f, then we will end up obtaining the opposite answer. Opposite means it's negative, positive, positive, negative. So what would be the solution for this case? When you set up the area, you say a to b. You write f of x minus g of x. You don't know which one is higher. So what you do, you put an absolute value at the end. That will resolve the issue. So if it's plus, it's done. If it's minus, it gets switched to plus. Last thing we need to talk about as an application is called the average value for a function. How do you find the average value for a function? We say the average value of a function f over the interval a to b is given by we call it FAVE for average, 1 over b minus a, the integral from a to b, f of x dx. Find the average value of fx, which is x squared, as an example, over an interval 0 to 2. So the average, f average, by definition, it says this is a, this is b. 1 over b minus a, integral from a to b, the function itself, dx. This is 1/2. Integral of x squared is x cubed over 3 from 0 to 2. 2 to the third over 6 minus 0 to the third over 6, which is 8 over 6. By 2, 4. By 2, 3. Make sure you reduce all the way.